ask our panelists to come forward and chat. So Chad Fowler is the author of Passionate Programmer, and he has been a
Yes.
so he's been like yeah, he's one of the oldest Rubyist guys around. He's embarrassing me.
I'm one of the oldest people here.
Yeah.
Thank you, Kobe.
And next, Yogi. Yogi is principal architect of Flipkart, and he has obviously worked in one of the largest deployments of in supply chain and Ruby. And yeah. Next person I'm going to ask is Baishampayan Ghose. BG, is he outside? Can anyone? So, yeah. I think
Yes, what?
I think you guys can sit actually.
He wants us to sit down. Sorry, let's sit.
So, yeah. Our next panelist is Baishampayan Ghose. He is a polyglot programmer. He is CTO of HelpShift, a startup running from Pune. And yeah. And last, I would like to call on Venkat Subramaniam. Yeah, he is CEO of Mahaswami Software. He has been programming in Ruby for like 10 years and for real long time. So. Okay, so we'll start the panel discussion by asking the panelists like, what is your current language of choice primarily and why? Swami, Venkat.
Okay, we use primarily Ruby. We've been using Ruby for the past, writing bigger size products since 6-7 years, but we use quite a bit of Java along with it. Well, see, there are some very well-established libraries like report engines and several stuff that you don't want to really try to match from the Ruby side. So we just bring the best of the both worlds by carrying forward all the good libraries. Drools we have used quite a bit. Jasper reports. These are all stuff for which there isn't an equivalent exists, and we just want to use the knowledge and the well-established software there for that purpose. So that's one of the main reasons.
So we use multiple languages, but Clojure is our main programming language of choice. We have been using it since, I think, late 2008. We're one of the first companies to put Clojure into production. We use Clojure because of a variety of reasons, but I guess if I had to name a few reasons, that would be Clojure lets me focus on the problem and pretty much gets out of the way. And there is a lot of focus on awesome things like immutability, data as a main construct for doing computation. And of course, it's a Lisp, so I get all the power. And it's also something that runs on the JVM, so I can also leverage the awesome Java ecosystem. So yeah, but at the same time, we do use different languages for different needs. We have used Erlang in the past. We use Go as well. And of course, there is JavaScript and a bunch of other languages.
So do you think like let's say, Clojure doesn't seem to be right language if I have to write a utility to do something on my OS X, for example, if I auto install something or manage processes or anything. Do you think like it's a right tool for that sort of thing?
So if you want to build a small utility, you'd need fast startup time. And that problem is inherent in JVM. And it's got nothing to do with Clojure per se. But Clojure also has something called Clojure script, which lets you write whatever code that you want to write in Clojure. But then the compiler compiles it down to JavaScript. And basically, you can create a Node.js application out of Clojure code. So you get all the flexibility and constructs to build abstractions that Clojure provides. But you can target different runtimes. So you can run it. You can build a shell utility as well.
Do you actually do that? You write command line programs?
We've done it a few times, but it's not something that we pervasively do. But yeah, nail gun is another approach that you talked about in your talk, right? And so yeah, so that's what we do. But there are other hacks like tweaking the boot class path in JVM to make the startup times faster. That's what something Leiningen uses in Clojure. So there are ways of getting it, but yeah, you are in a way right that by default, Clojure is probably not the right runtime for building shell utilities.
Okay. So before we move to Chad, like you said, like all the power of Lisp actually. So can you elaborate on that? What do you mean by all the power of Lisp?
Sure. So I don't, how many people use Emacs here? 20% maybe? 10. You do? Yeah.
No, I don't. No, Never.
Never. But you talked about Emacs as one of the good software systems, right?
Not to use though, just as an example.
Just to talk about. Anyway, so Emacs is a software which is 35 years old today and still is in production, so to speak. You can still use it. So what can we learn from Emacs? Well, the language is always available to you, right? So if you compare it with, let's say, Python or Java, so there is a difference between compile time and runtime. When you are running, the language is not available to you. You cannot, manipulate the code itself while it is running or generate new code dynamically. So that is one thing that Lisp dialects provide by design, because they have a property called homoiconicity, which basically means that the code and data are pretty much the same, even though they may not be identical. But for all practical purposes, they are the same. That means when a Clojure code is running, it can manipulate itself while it's running, and it can maybe generate new code or optimize something away. So basically, it lets you write code which writes more code. So, and that is something which is always preferable. So it's better to write code that writes more code than to just write code. So, and there are many other features that Lisp has. For example, the language itself is so simple, right? There are just few primitives to understand and learn about. Syntax is pretty much non-existent and very simple to understand and learn. And that really reduces a lot of cognitive overload that some languages might introduce. So yeah, I mean, these are probably a few superficial advantages, but I can go deep into it, but we can maybe talk about it offline.
Yeah, so Chad, like, what is your poison of choice?
My poison of choice?
Yeah.
I guess it's hard to answer that question. I don't have an answer. The one single answer I could give you is anything except for Ruby.
Okay.
And I mean that very seriously. I remember in 2007, I was at Mountain West Ruby Conference, the first one that Kobe was talking about earlier, and I did a keynote. It wasn't my first keynote. It was my first Ruby conference keynote. It was about like, what do we do next after Ruby? And I was already deep in the like toil and stress of being worried that I identified too heavily with Ruby in 2007. So I wanted to like get out of the Ruby thing and not be the Ruby guy. And I'm still desperately trying to do that. But no, I mean, like I said when I was speaking earlier, I'm using Clojure, Scala, Node, Java, Objective-C, Ruby, Erlang, everything at work right now. I think probably what I'll learn next really seriously is Objective-C, but I'm going to try to use it even on the server as like a language to develop services in, just as an experiment so that I can learn it better and do better job on the clients.
So like the not Ruby, is it because like you already had enough of Ruby? Like you obviously worked with Ruby as like with along with Dev Thomas and all these guys. You were one of the early adopters of Ruby. So like, or
yeah, because I will never learn anything else about Ruby because I know everything. No, it's I'm always suspicious of myself when I identify too heavily with anything extrinsic to me. Like for me to say I am a Ruby programmer, if I say that, I feel bad, and I know that I've made a mistake. I know that I'm creating some rigidity of value that is ultimately counter-productive to my success and to the success of people around me. So like I've been doing more Java in the past month than Ruby, which I used to do full-time in 1999. And it's been a really good freeing thing. Like, I am not a Ruby programmer, I'm a programmer, and even that is kind of limiting, because I'm more and less than that at the same time. So it's not so much that I'm worried about Ruby itself, it's that I'm worried about putting myself into a bucket that I can't get out of, even if it's a subconscious problem.
Okay, yeah. Yogi, yeah, so what you
Sure.
are...
So if you're asking about a personal choice, then sure, you know, I like coding in Ruby. I just love it just because it's compact. I feel the translation from my thoughts to code is shortest in Ruby, so it just feels very natural. But that said, I think I've moved over the last 7 years from being a kind of a language geek of sorts. Not really, but I used to love programming language theory and getting into stuff like that, but to actually not caring too much about it. I think programming languages are good and they kind of get you excited, but when it comes to actually solving hard problems, it's the ecosystem that matters around that language. Things like the tools, the profilers, the monitoring tools, debuggers, you know, that's the stuff which no language is going to save you when you're in production, right? So you just need to have that, and maturity of an ecosystem is really important there. Which is why we keep going back to the JVM over and over, and even the new languages that are being built on the JVM is it's for exactly that reason. But amongst the newer languages on the JVM, I'm actually surprised that I'm kind of intrigued by Clojure and Scala. We actually looked at Scala very carefully for this system I spoke about. But I didn't think it gave the kind of jump. I felt it was kind of marginal, the improvement over just doing good Java that Scala gave. That's arguable. There's a lot of language features there. Possibly too many language features, which is one of my concerns. But with Clojure, we looked at that also, but we didn't actually take it up seriously because of basically the prefix notation being too alien. We want something block structured for people moving from Java to Ruby, right? So I think, yeah, those are the kind of things that were on my mind.
Okay, so Ghose, do you, I'm going to call you BG, huh? That's okay. Yeah, so BG, do you agree like the programming languages do not matter all that much? Do you think like is the state of the art like the will not improve if like, you know, like...
I'll quote Alan Perlis here, and he basically said that programming language basically shapes the way you think about solving problems. So even if you do not use Clojure or Scala or whatever fancy language that comes out, you should try it out, because ultimately you're trying to solve a problem, right? You have the problem at hand, and you would like to look at the problem from different perspectives. So if you only have one way of looking at the problem, then you know, by repeating the same approach 1,000 times is not going to help you. You should look at different ways of maybe approaching the problem or even understanding the problem itself. Simple example, parallel processing can be done using threads. You can use coroutines, you can use CSP, you can use actors. What should I use given any situation? So even if I don't even know about actors or CSP, I'll never be exposed to that line of thought. So the goal is basically to learn a language, not to just switch wholesale to that language, but to be able to appreciate new ways of looking at solving problems.
Yeah.
Yeah. So I think that's a great point. And when I missed mentioning this, when I was a programming language geek, I think the one important inspiration for me was SICP, right? Structural Interpretation of Computer Programs, and that's something which again goes back to what are the fundamental abstractions that you can reach out to solve problems of different natures, right? And it goes to the crux of it. You can use data as abstraction, procedures as abstraction, stream processing, and actually creating languages of your own. So the point is that there are far more paradigms, right? And I think getting a grasp of those paradigms is very critical. But for that, you don't necessarily need to go to every new languages around. I think you need to see what ideas are implemented well in which language, what can you adopt. Like for example, after reading SICP, I think my Java programming became so much better. I started using more anonymous functions, online classes. But yeah, that's ugly. But so yeah, so I totally agree with that.
Cool. So, you talked about like how many of you have heard of like something like or used the actor pattern for any sort of concurrent programming? Can we have a show of hands? Okay. So, anybody wants to explain? Like, yeah.
There is nothing to explain. Just go and read on Wikipedia, maybe. And RTFM, yeah.
Okay.
So,
so which language you think like does the whole actor pattern programming properly?
Yeah. So actors are well implemented in Erlang and Akka, if you are using Scala. So take a look at it. So, again, this is not a silver bullet, right? Again, go back to your own basics. Fred Brooks told you guys many years back, there is no silver bullet. So actors will not solve all kinds of problems for you, but you should be aware that there is another abstraction that I could probably leverage to solve whatever problem that I have at hand. CSP is another thing that I briefly alluded to. That's something that is embodied in Go. So Yogi just said that you don't need to learn a programming language, but look at systems where all these ideas are well implemented. But I would also argue that not all ideas can be implemented as well in all languages. So you cannot, for example, Java does not, Java 8 has something called lambdas, but Java 7 does not have anonymous functions. So if I really want to understand the value and virtues of anonymous functions, I cannot learn it through Java. The closest I will get to is dependency injection. But that is yet another level of abstraction, which basically removes me further away from the core goal, right? So there are languages which are designed to leverage certain principles. Go, for example, is built on top of CSP, right? And channels are a first-class thing. Erlang also has something similar. So maybe learning those languages will expose you to those ideas much better than some other language.
Chad, you want to?
Yeah, I think from the perspective of learning the paradigm, I think Yogi is lucky that he is smart enough to read a book and then get all these things. My experience is not the same, and I'm honest about that. I don't think you're not being sincere. I think some people, including me, have to actually use the thing, not just the language, but the paradigm. So like, I can read about actors in 5 minutes. I totally understand it from a theoretical perspective, but it takes a while, and it takes actually trying for me to really get where it makes sense, Yeah, to appreciate it, and also to appreciate the edges of it. So I actually think, like, I've been trying to get out of Ruby, as I've been saying. I mean, the truth is, I have learned I don't know how many programming languages since I started doing Ruby, but I have never stuck to one. I have, but I have really stuck to one long enough to where I really, really thought like that. And like the best case scenario for me in picking up these other paradigms is to like get so into Go programming that then I go back to Ruby and I go to do something and I don't try to implement channels. I just say, damn it, channels aren't here. I'm frustrated now. And I see that this language isn't perfect because no language is. But you can't get to that point. And that's like where the maturity comes from, where you're not in love with any certain thing, and you see the entire landscape. And this is part of why I can't answer the question of what my go-to language is right now. Like, I'm doing a lot of Scala because there are certain things that I'm working on that work really well with actors. Like, I can conceptualize them with actors, and that's what I'm gonna write it in Scala because we already have the JVM, so therefore it's easy to do Scala versus Erlang.
So, but there's a problem here, the way you approach programming language. For example, like in Ruby world, for example, like Eric Hodel or Ryan Zenspider, these guys are maintaining tools that you have written actually for many years back. And those tools have, like for example, Ruby Gems didn't have proper test suite for a while actually. And like the building ecosystem.
That's because tests are a design smell, that's why.
Yeah, my point is like building building tools like of a language around a language takes time actually. Do you think like, for example, like Eric Hodel and these guys are probably working with this thing for like 9 years or so, and they're still doing it, right? So like, how do you like, if like, you know, like, so how do you fix that? Like, you need to stay long term in a language to really change it, right? Or like, am I wrong here? Yeah.
You mean you need to stay in it to change the language
So
itself?
change the language or build like the infrastructure or the libraries, gems to support it.
Yeah, somebody does. It doesn't have to be me, right?
Again, so let me add something to what Chad said. So Chad said that I don't want to remain a Ruby programmer. I think what he means is the Ruby mindset, okay, or any mindset thereof.
Yeah.
It's not about writing just code in that language. So you can still be a Ruby programmer for 20 years, but that doesn't mean you keep the same mindset all the time, right? There are things which are not even new, but we are not discovering those things because we are not looking beyond Ruby.
Can anyone else? Sorry to cut you. Can anyone else carry the mic and give it to the audience actually? Because
so
there's
it's
no
not
mic?
just about Ruby per se, right? It's about it's applicable to any language like JavaScript or Scala or even Java for that matter.
So this is kind of intrinsic to something interesting to how we actually select a language or set of languages to develop these days. Depending on the nature of the problem, I guess you pick what is called like a language to which other languages can actually circle around and support various smaller problems, whereas this core language that you're picking is solving like majority of the nature of the problem. For example, web application, but you got some parallelism stuff that you need to do, or you got some functional programming stuff you need to do like Scala. So you probably pick one language like Ruby as to kind of like hold everything together, but you do have these other languages in which you actually solve problems differently. So it's more of, but different problems, in some contexts, Scala may be the core language, and you may want to wrap it around Ruby a little bit, or maybe other things a little bit as well. So it's more of starting from an architecture of the nature of the problem, but being polyglots, you have this choice now, not to implement it and struggle with one language, like you were just talking about example where I wish channels were there in one particular case. But now you could pick, if you can become a polyglot and learn these other languages to a good degree, you could pick other languages to complement it and solve those specific problems. So this seems to be one approach that's kind of like intrinsically developing right now.
I have a point very closely related to what you're saying. Based on like especially what you said about languages, right? Like a general message could be use the right tool for the right thing, kind of a thing, right? But the problem could be that not everyone can pick up. So when you go into a code base and let's say 5 different languages are being used for the right kind of problems, so they are doing the right thing. But for someone to go into that code base and pick it up would become very hard, right? Because not everybody is tuned in that way. So that's like, so polyglot comes with a very heavy cost of being able to replace yourself. At least that's been my experience. So that's my first question. And like adding on to that, it's very easy, like you said, to pick up a book, read through it, or go through some tutorials or whatever it is. But like Yogi was saying, how his team had they needed about 3 to 4 months to start writing idiomatic Ruby, right? And that is a big deal because in those 3 to 4 months, it's critical that you keep churning out code, right? Your software, you can't come to a halt because now you're getting this new language on board. You guys had the luxury of having an existing system, which was, and you were replacing that system, but that's not necessarily always the case. You have to, right? So, yeah, so like my second point was around, like that was the first question, polyglot recruiting and things like that would become very hard. How do you do that? Second, it's easy to pick up a language on a theoretical sense, but to be able to start writing idiomatic program while also delivering production quality code, do you guys have any experience about how you got that working?
That was the second question here that I was about to ask actually, which was like at least one part of it, like how does an organization adopt a new like language? For example, in Flipkart, like, or the company where all of us work, like like there's a like engineer, a programmer decides I'm going to build this thing in Erlang, or I'm going to build this thing in Go, and there's nobody else Go, so nobody else doing Go. So as like you guys are senior person in respective companies, so do you tell to that guy, no dude, our deployment system is tuned for like JVM deployment or Ruby deployment and the whole package management or whatever, and don't write this. So like there is a aspect of like adopting a new technology, hiring, and like the skill barrier of entry, like in code bases which are like. So how do you tackle that problem in general?
So it's a hard problem, right? So at Flipkart, we were already fairly polyglot. For example, the website is in PHP, the search engine is written in Clojure, the UGC system is written in Scala, Java is all over the place, Ruby came into supply chain, Node.js is there in the seller platform and marketplace. So we were already there, but we actually ran into a few problems there. So when I think that the question about technology selection is actually quite critical. Very often, a lot of it is mostly blog-driven decision making, right? And that can be quite scary. So we've started to put in some kind of process. It's hard. It's not worked so far. We've been trying it for 1 year, and the process is like, okay, go up to somebody else on the team and just ask them, just bounce off your thoughts first before you kind of take up a new system, a new technology. So we're trying to formalize that. We failed miserably at it. But right now, what we've instead focused on is interfaces. So we've become fairly diligent about making sure that the interfaces and contracts are good between systems, and then that the systems can evolve independently, whatever tech stack they use, as long as the team is committed to it. And it's not a completely way out language. So we've moved from being predominantly thrift-oriented interfaces to HTTP. And that's added a huge amount of value. Sure. So thrift is a binary protocol which came out of Facebook, I think. So it basically gives you both a RPC endpoint and a data serialization mechanism. So it's basically like what Corba, but it's basically gives you a fast.
These people are too young for that. Actually.
Yeah. Oops.
What is Corba?
Yeah.
Do not ask that question.
That will be a big panel discussion by itself.
You have to be at least 21 to hear about Corba, and not everyone in this room is 21.
Protocol buffers. Okay, it's more like that. Okay, anyway. So, sorry?
You can keep a long-running TCP connection with
with thrift, you can do it. Yes, I think so. Yes.
You can keep a long-running TCP connection open too, which makes
Correct.
performance better than HTTP in some cases.
Right, but if the moment you move to HTTP 1.1% connections, that's kind of taken care of. So yeah, most modern libraries have that. So
We are digressing, I think.
yeah, where were we?
We are digressing. You were like
Let's keep digressing. Let's go.
the language, like the contracts of
Right. So we become pretty diligent about contracts. So HTTP and the actual and actually having sensible REST endpoints resources is become kind of de facto, and that's actually helped a lot. So systems within Flipkart are extremely open. You can actually query them pretty easily to extract data, not push data to it. But yeah, so I think that works. And then each team can independently take decisions with some guidelines and hints. So we'll kind of prod people towards a few languages and technology stacks that have worked, but not insist on it. So if somebody goes out and says, Elixir is awesome, and for these reasons, we'll at least ask them that, okay, does it check a box on tooling, on some amount of profiling or monitoring, and basics, a small checklist of sorts. We've not implemented this yet. It's probably shit's going to hit the fan when we kind of suggest it, but yeah, that's the idea.
Our solution is a little more messy, I guess, as you would probably expect from me. But like you said, not two-way out language. I like the way out languages, and I would like everyone to be able to do any weird language they want. Because I hate that being a thing that people talk about and are frustrated about at work. It's such a stupid thing to worry about. So as I talked about in my talk this morning, I will tell developers, any language you want, fine, go ahead, but you have to write very little code. It has to be a very small, well-defined thing. We are also working very hard on the interface definitions, and that's why I was talking about that JSON schema validation stuff, to add one more layer of monitoring to it. But most importantly, I want to hire people that I trust, and I want to show them that I trust them. So if someone really, really wants to do something in Elixir, and I have one guy who really, really wants to do something in Elixir, He actually proposed it for one project, and I said, fine, whatever. Then we realized we needed to do a lot of stuff that talked to Amazon SQS, and there was no good Erlang library or Elixir library we could find, so we did it in Scala instead, because it was easier. But he made the choice, not me. And so, like, we have one thing in Lua, even, in Nginx. I would love to have, like, assembly and Objective-C on the server, and, you know, maybe, I don't know, Visual Basic, does that still exist? We could do that too.
Oh, it does.
Yeah, it does. All right, awesome. Server-side Visual Basic.
Okay.
So I guess it's more of a cultural problem. It's not really a technical problem.
Good, yes.
And I think it can be solved by setting the right expectations. And what Chad said, totally agree. Trust your team members. Give them the opportunity to try out new tools and prove them. So what we do is that when a new programming language comes out, anyway, as such, we are using a cool and really hip programming language. But if something cooler comes out, like, I don't know, something might come out tomorrow. But we always have encouraged people to try out new languages and maybe build an internal project and show it to others. And we take a collective decision in such cases. But yeah. So I think it's more like a cultural situation, and as far as hiring is concerned, I think it's better if you hire programmers instead of Ruby programmers or Java programmers or PHP programmers. Get people who can write code and who can learn new things, because even in the Ruby world, you are doing new things every day, right? If you cannot learn new tools or techniques, then you are stuck. A code base. You are talking about a code base. So idioms are formed over time, right? And they are also learned over time. So if you are working on a sufficiently complicated code base, anyway, it will take you some time to grok it. If it's an existing code base, or if you're trying to learn something and to build something fresh, it will take you some time. There will be some iterations, right? And that, I think, is perfectly normal.
Yeah, I actually meant to answer the idiomatic thing. If it works and everyone can understand it, I don't really care. Like, let it look like Java code written with Ruby syntax. Doesn't matter if it performs and the person enjoyed doing it and it didn't take them forever, and it's not completely confusing. And my answer to that is keep it really small. If it does, it doesn't matter if it's idiomatic at all.
But there's
another thing, just one thing, Hemant, and I'll add is that how do you really define idiomatic code? Okay, a code in which you are able to leverage the features of a programming language the best is idiomatic code, right? So if you're championing a programming language, if you're trying to introduce a new programming language to your company, and of course you would like to exploit all its features, right? Unless it is handed down to you by your boss, right? So if someone is championing a new programming language, it's his prerogative to to learn what the idioms are, maybe figure them out over time.
There's
Just
yeah?
one thing to add.
This is not working?
That doesn't seem to work. Okay. So it's going to be a slow process, obviously. We're just talking about lots of languages, and the key thing is, are we doing in-house? We have control of the deployment environment versus we're going to consult. So for example, Flipkart, or in several cases, that there's a lot, you're in control of the whole thing, and you basically decide, or you live with the consequences of the whole thing, right? Then when you're dealing with a customer-based solution, obviously there's a lot more constraints as to, he will look for some things that he can hire more people to work with, as opposed to just you, and what if you go away, and in-house also same problem. So probably to start with, just learn one more language. Just learn one more language and start using it, and it's going to take some time. Like you said, it's just a cultural thing, but particularly in India, the context is not just, just start with one more language, try to use it in an environment, so it doesn't look like you're grabbing this opportunity to throw as many languages possible into the solution you build, just for the sake of learning new things. But just do one more language carefully, but in order for you to do that, you probably will have to casually learn 5-6 languages. And you may want to pick that language that you want to add. And it's going to be a slow process. You're not going to be able to parallelly deliver all these and then introduce a new language just like that next day.
Yeah, when I started learning Ruby, I started using it in 2000 at work, and it was to generate Java code because no one would let me deploy Ruby, so I just wrote Java generators and I wrote everything like as a DSL in Ruby.
Yeah, absolutely. My first experience with Ruby was not really mainstream. We were just doing it's called load test conductors, a little open source thing that we were just doing. So what we wanted is we wanted to drive these command lines, and Ruby was the language to do that. So there are opportunities for you to use new language, may not be in your main code base, all the supporting tool systems as well. So there's a lot of opportunities. So you need not look at it as, can I change my main language? Or how soon can I do it?
So
one of the, I don't know, this thought that has been kind of crossing my mind repeatedly and kind of worrying me also. So I used to be kind of involved in the language choice wars a lot and always on the, try out something new side. And I kind of discovered a completely different way of working. And at Flipkart, some of the other people who've been there, they kind of shook me out of maybe my ThoughtWorks influence in a certain way. And there was a very key point when that happened. So I think the difference was this, right? The takeaway was that if I'm arguing about a programming language, I probably don't understand the problem domain well enough, right? And I've seen cases where systems have been built which go fundamentally to what the problem being solved is really about and model the core abstraction so beautifully that then doesn't, or even identify the core abstraction so beautifully that doesn't matter which language you implement it in, because that problem is solved. And even before you start implementation, and that is beautiful. I think with this agile perspective, I think somewhere that has got lost. We try to kind of get into implementation much sooner. So if I had to actually go back and say what is the most my favorite programming language, I think I would say domain-driven design actually. I would actually just recommend people to, and I actually do that on my team also, to actually read that book and understand it deeply and try and apply it. Because I think a huge set of wins are possible from that without even going down to the programming language level.
Yeah, the programming language is a tactical choice, and in most cases, right? But the domain, it's like what you were saying about performance earlier. You could use Java or you could use JRuby. Doesn't really matter because the database is going to be slow, right? When it comes to application design and architecture, it's really a hierarchy. So domain-driven design is at a level higher than the languages. I would still say that the languages make you think differently, and some languages suit different domains better. And having really open-mindedly gone back to Java recently for various reasons, I can tell you that it's terrible to use. It really is. It wastes my time compared to Ruby, compared to Scala, compared to more modern languages. And it's not a knock against Java. Java's older and doesn't have those benefits. So I think tactically, it's a bit of an exaggeration to say that the language doesn't matter, but I get your point.
Sure. So just as a counterpoint to that, actually, having gone from Ruby back to Java, there's a few very low latency systems that we had to build out recently. And those were built with some of the newer Java stacks, like say Drop Wizard, which has got Hibernate integrated into it, and Netty, and so it's basically gives you a complete stack. And actually the systems and the designs that came out of it were actually pretty good. And I was surprised and actually happy to go back and look at Java. And I'm actually really looking forward to Java 8, more than Scala in a sense.
That's good, because so the Java 8 you mentioned, and then Scala. So there's a couple of things, like if you talk about like just Java like and Scala, like why would you choose, like for example today like Java 8 is not released, but why would you choose, like is there any reason to choose like Scala over Java now actually, like if you, because Akka, for example, Akka Actors is a good system, but it is usable from both the languages, right? So is there any reason to pick Chad?
Yes. I mean,
like,
so the question is there any reason to pick Java over Scala or Scala over Java? Does one win?
No. Just Java, like Scala over Java, actually. Like.
Okay. Scala, or should you actually, because of Java 8, does Scala need to be?
Yeah, or Java 7 even.
Java 7, then yes. Like, for me, I see Scala as like totally over-engineered in the same way that Yogi almost said, but like too many features. And I'm even writing a book about it, but I kind of hate it. That said, you can program Scala like Java with less annoying syntax. You can do that. You can make it be like a Java program. And if you do, I would argue very strongly, and this is subjective and maybe even kind of fashion-oriented, I would argue that the Scala code is better to look at and easier to write than the Java code. There's less typing, and I mean that in two senses. Less typing on the keyboard and less having to explicitly type because of type inference. I'm sure, like with Java 7, there are no lambdas. With Java 8, I'm sure it's going to be some sort of anemic thing that doesn't quite work the way we want it to. It's perfect in Scala. There's a lot of great stuff about Scala as a next evolution of Java. But you can also, like Ruby, with metaprogramming and eval and all the crazy stuff you can do, you can completely shoot yourself in the foot with it too.
So when we compare these languages like Java and Ruby and all that, the thing that we kind of focus on is the amount of volume of code. Volume of code doesn't lead to the ease of understanding. One of the things that Java really does well is things are so simple. There's no this implicit stuff happening behind the scenes and all that. And really very well factored Java code is not so ugly to look at. If I've written all small methods and composed stuff out of it, it's not so ugly to write or ugly to look at. So
I would like to answer that even if you're not asking me, because I could imagine myself saying that if I were in the audience, but right now I strongly disagree with you. I think Java is simple as a language, yes, but what it leads to is, because of its lack of flexibility, it's not the volume of code that I hate. I mean, sometimes it is. Sometimes it is literally because I have to type date equals new date. I don't need that. But it's also the ability to be expressive. And to me, that's where Java strongly lacks. It's pretty good as a system language, like at the point where you decide you need to make that distinction, but maybe as things get faster, you don't need to anymore. But I believe that the abstractions that people end up creating for Java, at least idiomatic Java, like in the Java world, idiomatic is a bad sign, I would say, because it leads to this kind of pattern soup thing. And it's true that you can reason about it because it's statically typed and there are less opportunities for metaprogramming, but it's a slow process in my experience of reasoning about it because you get so far away from the domain, creating all these factories and interfaces and crap just so that you can make it testable and pluggable, that the actual logic and the core of the business gets lost. Anyone have a point to make on that?
So yeah, I totally agree with Chad here. The Java, the language, is designed to be very simple, but at the same time, it's also very rigid. So imagine explaining philosophy to a kid, right? The kid probably has a vocabulary of maybe 100 words. How do you do that? You cannot discuss the existence of God, or maybe the nature of knowledge in front of a kid, because the kid doesn't have the vocabulary that you need to communicate with the child, right? So what you will end up doing is oversimplification. So by the time you simplify the concepts to the primitives that the child can understand, you're far away from Aristotle and Plato, So that's the example that I would give you.
I have a question. At what point do you feel comfortable or something like a threshold level for new languages to be used at production node? Like there are some languages which are coming up now, but still you know that it's not something used. As for me, I would probably look at an example if I would say, okay, there are quite a few systems, big, huge systems built on Ruby. I could recommend it to some more people who would come to us saying that, okay, fine, is Ruby safe? Yeah, it is safe because there are people who use it. But at production level, when there are new languages, how would you feel? Okay, at what point do you feel comfortable to say that, okay, this is stable to use at production mode?
Fantastic question. I would say that this is a taste that you need to develop over time, and it, I think, comes with experience. The more you learn about different programming languages, the better you get at evaluating them. But having said that, community support does matter, but it's not the only. Okay, you can have a language which would have a huge community around it. That does not necessarily equate to the language being awesome. Okay, documentation is also another thing. Library support is also another thing. But again, I would say that one of the ways is to really see what is the USP of the language. What kind of problem is the language helping you solve, okay? If you see that it's like you already know Python and there is Ruby, not really very different, honestly. So, but if you see Go, again, very different, a lot of interesting concepts. And you might find problems where that language might fit in just perfectly, right? So it's okay to maybe wait for adoption by a larger community, but sometimes you have to be the champion yourself, right? Someone started using the language first when Ruby came out, right? DHH was the guy probably. And that's why he's worshipped today. So why not be the DHH yourself?
Yep. Yeah. So I think there are quite a few kind of milestones for a language to go through, but I think the most critical. So again, it depends on the kind of client that you're kind of suggesting this to, right? Like if it's a small startup, then sure, you've got a lot more flexibility. If it's a larger system, has to scale, you've got different constraints. But I think by and large, the existence of a very low latency production profiler or runtime monitoring system is probably that milestone. Moment that is in place, a profiler which can actually run in production for that language, I think that marks a very critical milestone when that language starts evolving at a very different pace. Because you start kind of finding issues which you would never have been able to find before, right? So for example, with perf tools, we've been able to do amazing things in production with Ruby, which was just not possible before we knew. Even the commercial alternatives like New Relic for that matter, right? So either a commercial or an open source production profiling tool, I think is a pretty significant milestone.
Got a couple of questions here.
Right, Yogi?
I don't know. I haven't used C in production.
C has a production level compiler which you can plug into a running system.
No, but so there are built.
Yeah, and
But
there is also Valgrind, but which is not
sure.
probably. I think what I will say is that Yogi is talking about the presence of a profiler being very important. I think again it depends on the domain that you are in, what kind of company you work for, what your challenges are. It could be just documentation for you, right? Or it could be just the existence of a OAuth library for you, right? So I think it depends. The real answer is it really depends.
Hi. Hi. I have a question. Like, when do we actually choose an interpreted language versus a compiled language? Is my first question. Like, for example, Ruby is interpreted language, and like Java is kind of both. Like, when do we actually choose that one? Is the first question, and second question is, like.
Please ask one question. We'll have time for another question. Please ask one question.
Yeah, the question is asked.
When compile language
Okay. So okay, again, this is as Baishampayan said, it's kind of a black art. But roughly the heuristics that I use is primarily determined by is the system going to be CPU bound or IO bound? What kind of latencies do you need? Do you want sub 10 milliseconds? Stuff that you need to do. I'd probably straight away go to Java or any other statically typed language or which give those kind of performance. So I think latency is one. I don't know. You might.
So I would say that the differences between interpreted and compiled languages, they are kind of like blurring these days. I think what you really mean is a native language versus a language that runs inside a VM. Okay. So I think VMs are as fast as natively compiled languages today. And so, for example, one of the lowest latency languages would be Erlang, but it's not really a natively compiled language, for that matter. So again, yeah, Yogi is absolutely right. It depends on the problem. If it's CPU bound, maybe you should use a language which spits out a native binary, or maybe has a very fast JIT compiler inside a VM. Or if it's IO bound, which most web applications are, by the way, then just use Python's Ruby or whatever, or JavaScript.
Yeah, but it is a blurring not only of that boundary, but a blurring of concerns. So like, you said you would never use Ruby for something that requires that low latency. That's because Ruby's not fast enough, not because it's an interpreted language, right? Exactly. If it were, yeah. So I would personally say, on anything where I don't mind having the source code present, which means any server-side thing, for example, I would use interpreted languages if it's fast enough, because it's a pain in the ass to compile it. I don't want to have to do that. And what all of these things do with the VMs are effectively just compile it for you anyway when you execute it, right?
Okay, my question is for all panel member. From invention of a computer, we have seen that there are so many languages came and gone, and each language ride on a wave at some of the other time. As we said that today is Ruby is one of that language which is riding on the wave. C is the only language which is there for a long time, and it is from the starting of the computer and still it is there. So my question is, how long do you think that the Ruby wave will last? And what is going to be the next wave? Will it be Clojure, Scala, Go, or any other language? Because now the mobile is coming into the market and total paradigm of programming is changing.
Great question. I will just, a minor correction. The oldest language that is still in existence is Lisp and not C. It predates Unix and Lisp and C by 20 years. And anyway, so
it's a huge wave, is what you're saying.
Huge wave. Huge.
We're still in the Lisp bubble, which will soon burst. Everyone will realize that it was stupid. Do you really want an answer to that question? No, we didn't really answer it.
Languages do come and go, but paradigms do stay. Okay? So fine. Don't focus on languages. Focus on learning different paradigms.
But they don't really come and go that much. I mean, think about it. Like,
yeah, they might, right? PHP fell off of favor. Right?
But it's not. No, it's out of fashion. It is
exactly.
heavily deployed, right? You're running it, so it still exists.
a bit sheepishly, but running.
Remember one thing, Ruby is older than Java. It's been there since 2004, but how many people started referring to Ruby until Ruby on Rails came? So it's a solution that language or a framework provides is what inspired everything. In fact, Ruby on Rails inspired the entire ecosystem, much more of other languages beyond just Ruby. So that's, in fact, it's a Ruby on Rails that made Ruby popular, not...
It's also Ruby's Achilles heel, by the way.
Absolutely, there's a downside to it, etc.
Monkey patching, FTW, right? Not.
But remember, we were doing all this web XML business till Ruby on Rails came about and all these other stuff. So what changed? If you were to call it, you can call it Ruby on Rails wave for that matter, rather than Ruby.
Are you saying that like the whole REST thing was because of Rails? Venkat, like.
Certainly the movement was more simplification, convention over configuration. So that's what the Ruby on Rails was inspiring. So you could just say that people who are doing Ruby on Rails were doing more REST than people who are doing .NET and doing the SOAP business. And by the way, SOAP seems to be effectively dead, right?
But unfortunately, it's dead in the same way that PHP is dead. Still exists.
No, true. It's the same way COBOL is dead, right? COBOL still exists.
And Corba, for that matter.
Yeah,
sorry, kids.
And that'll never go away, as long as mainframes are there.
The next question that I wanted to ask is like, Yogi talked about in his presentation using a service architecture, like kind of interface based for like multiple small micro applications, small applications. So the next question is like, how do you go about in an organization? You have a product, or maybe more than one product. How you go about building a true polyglot system where like programmers are encouraged to come and like use different languages? Does this require like some previous thought, or does it happen automatically? Like, yeah, what are the best practices? Anything?
It's for one of us, isn't it? Well, he says it's for me, so I say it's for you. Okay, so actually, Yogi did sort of answer this a minute ago. You really do need to focus on the architecture of the system first. That's essentially what my whole rant was this morning, is about the architecture of a system that's made of small components that interact in well-defined ways with very clear responsibilities of each component, and the components can and will be thrown away. I think for us, once we have that set up, I really can say, yes, write a service in Rust. I don't care. I don't even know what it looks like. I haven't bothered to read about it yet. It's fine. Yeah, it's like C++. So yeah, it's excellent. It's battle-worn. But if it performs well enough and it actually works and we're monitoring it and doing these, and it's deployable in the way that we can deploy, I don't need an ecosystem for polyglot programming then. I just need to encourage people to try things and to throw them away if they didn't work out.
Venkat, you had something?
Actually, this is something we were just talking about this morning. We have to move away from a language requiring to be hidden under web services just to be safe and you can throw it away later. I think the languages will have to find a way to work together where you don't need to hide things behind REST. All these languages will have to come with a way to improve whereby Ruby should really see a world of coexistence with Java and world of coexistence with .NET. Because in many cases we develop in, like JRuby, right? You develop in Ruby and you deploy it in Java, or J2E with all the monitoring tools, and you talked about profiling. JVM and the JVM ecosystem is very great for deployment. It's actually battle tested. So in order for you to use it, the Ruby language has to become friendly with Java. A simplest thing is, for example, RJB, which is a bridge to Java, which is still be used, by the way, over and above JRuby as well separately. So you need a way to actually have one language talk to another in somewhat standardized, simpler, less overhead mechanism. And I think that would really encourage people to use different languages without having to build this SOAP layer or whatever REST layer.
So you're saying at like binary level, actually like a foreign function interface, and I think the simplest way to do that is still over the network, right? Like whether it's REST or it's 0MQ or whatever, right? It's like independent processes just interacting with each other, isolated, not messing with each other. It just works well. Not convinced that RJB or...
About it from an architecting a bigger system standpoint. But I'm just talking about simply, I'm running this web application, but certain part has to be parallelized. I should be able to do it with less overhead, less new layers. If a simpler problem exists where that's applicable, right? I mean, whatever you're just talking about is applicable at certain complexity and certain layer. But generally encouraging people to apply multiple languages to a single solution right now has so much overhead. I mean, today colleges are teaching kids, people different languages, but it's as if like, if you don't get a job in Java, then go and look for a .NET job. That's really how you're learning multiple languages. So, but we are not, it's not that we are not learning multiple languages, but we're not polyglots by default or by simplicity of the system. That is, I believe, if you want to encourage polyglotism, we just have to go to the next level where languages will have to coexist with each other.
I think
languages will have to be built with that notion.
Fair enough. So I think coexistence can be looked at from different angles. I think what you are talking about is runtime coexistence. You know, inside one runtime, you have multiple languages running. I don't know whether that's technically feasible.
It need not be a runtime. It need not be a single process coexistence.
But then it would have to be. It would have to be over some network, right?
No. For example, take RJB.
Okay. How does it work?
It's almost like you're just calling another process in some kind of.
But how does it really work?
It could even be, you know.
Yeah, it's still one process.
In case of RJB, it's just
still
one
process, right? So if
but JVM does its own thing, right? In a way, JVM has its own layer.
But ultimately, it's all JVM bytecode.
True.
Okay. So I think we are all building or have to build distributed systems at the end of the day today. And we are also trying to build abstractions, right? That is the whole goal of building a software architecture. That let me find out which parts I can abstract and how. So what Yogi talked about, I totally agree with him. I think the best approach is to abstract away the orthogonal concerns and components of the system and tie them together using one language that is spoken on the system. So I think they use JSON and JSON schema for the HTTP. JSON HTTP, okay, yeah. So but you could use, you guys use it. You could use a message queue or maybe use something like 0MQ sockets to communicate over and maybe use thrift or even JSON data for communication. But so idea is to basically build a system of orthogonal components but tied together using one system. But then for the message bus, you can either use a socket or a message queue.
So there's definitely a lot of tools which are like runtime that exist today which allow runtime reuse of languages. For example, like either on top of LLVM or on top of JVM, where you know, like you have closure collections you can use from JRuby. Actually, there are projects that allow that. Do you think that all those are basically toys and shouldn't be used with any seriousness?
Closure collections are not toys. But what I would say that I think this idea, it can be applied to the JVM languages. But many times you will have to use some language which is not available on the JVM, right? And you cannot use LLVM for that because it's something which is much lower level than the JVM. So you will have to use the network to communicate over each other. But as far as JVM languages are concerned, yeah, why not? At a theoretical level, interop between languages is something that we should shoot for, absolutely.
So I have a complaint and a question here. Complaint, you're agreeing too much. We want to see more disagreement. So
Agreeing to each other.
Closure collections are a toy then. No. I actually, when he was saying, are these things a toy, I don't mean closure collections, but I do think that the whole idea of interop in a VM or in a process is overrated. And I think it's overrated. Like I remember being at Foo Camp talking to the Parrot guys and LLVM guys a while back in a workshop, and they were all complaining because they had tried to do like JavaScript on all these different VMs. They realized that like an array in JavaScript has different semantics than an array in Java and an array in Ruby. You know, if you add something way off in the distance past the end of the array, in some languages it's an error, in some languages it nil fills, in some languages it's, you know, so like that's a really stupid example, and you can all imagine there's some way to solve that. But with the more interesting features of the language that lead us to want to be polyglots, like I don't really think it makes sense to instantiate a Ruby class from Java, for example, because the Ruby class does different things than the Java class, and vice versa. Yes, it can sometimes be nice. So like when you're in Clojure and you want to use someone's ancient Java library that has been working for years, you just do it. When you do it though, it's hideous, isn't it? Like the Java interrupt is really not nice, and you know you're doing, it works fine, but it's uglier than Clojure code, right? So then you want to write something so it looks like Clojure and feels like Clojure. So like personally, I think an operating system is also like one process. You can think of it that way these days. It didn't used to be the case, but I can spin one up and start running it and then have language interrupt with multiple processes in there talking via sockets. And it's conceptually not very different. Like if I describe it to my mom, she won't know the difference between that and a virtual machine. So. Oh yeah, domain sockets in Unix. Of course, this might be the solution then.
quick question to all the panelists. As we stand today, what is the minimum number of minimum set of languages you would recommend to all the programmers? All right.
Did you tell him his question was invalid? Is that it? I disagree.
So Anand is trying
I think
to...
it's a really awesome question. What I would say is that maybe don't worry too much about the number of languages that you are learning, but number of different paradigms that you are learning, right?
So the question was like a kind of a paraphrasing, like, so...
It doesn't matter. So look at the paradigms. If you already know C, then don't bother about C++, you know, for example, or whatever.
So yeah, so the next question I had here was like, I'm just a bit jumping back and forth, but like, yeah, what next programming languages, like for example, you guys are looking forward to, like, you know, like starting with Swami, like, sorry, Venkat, like, Mike, so, yeah.
Okay, I'm just looking for a better Ruby.
What do you mean by?
More of, I'm just looking for a standardized Ruby where I should be able to switch between the Java world and the MRI world without lots of friction and, you know, and better performing Ruby, generally speaking. And as much as we just talk about low level, you know, you're talking low latency stuff. I think we can't keep saying that Ruby is, you know, it's slow for a reason, right? Ruby can run, you know, hotspot. One day Java was slow because of before hotspot, but Java became very, very fast over a period of time, and lots of new work has been put in there. So there has to be some research into performance in Ruby, I think, something. So I'm just looking for better Ruby is essentially for my investment of time and language. But certainly, I mean, I would like to learn Scala and stuff like that, something.
So for me, learning new programming languages is more like a cognitive exercise to expand my own thought processes, not specifically to, you know, apply in production. So the new language that I'll be learning in 2014 is Factor, and you should check it out.
I was going to say Factor. We should not sit next to each other.
Yeah, and
We're
but
too
why?
similar.
Can you just like, why exactly factor?
I would say factor because it really hurts it hurts in a non-stupid way. Like if you learn befunge, it hurts in a stupid way. Like there's no reason to learn befunge except for fun. Factor though, there's something clearly there, right? It's concatenative programming. It's a different way of having to think. And it's a different way that, to me, feels like it's deeper than it is stupid, you know? So actually, I wouldn't probably learn it now, but I almost said that, though. It was on my list.
I already know APL and a little bit of J maybe, but APL is, again, another concatenative language which inspired Factor, but APL is some language which I can read but cannot type, because to type APL code you need a separate keyboard. That's why I'm learning Factor this year.
Yogi?
I don't know, Sanskrit maybe. I've heard there's some parallels
Sorry?
between. But yeah, I think Go or Haskell, I think they're the most differences from what I already know. So
Fair enough. So I think a lot of us regularly learn programming languages, and then the Dave Thomas in his book, like Pragmatic Programmer, recommends like learn a programming language a year actually. And so one of the things that I have been wondering is like, how do you exactly like go about learning a language? You cannot, somebody cannot come Flipkart and deploy like a production system in Haskell. That I don't know if you allow, but we talked about that already actually. So, but like, how does a person, like when picking up a language, go about learning a programming language, and like,
I think I've probably got the, yeah, well, I actually read the manual. Yeah, I'm so boring. And so I typically just read the manual end to end just to get a flavor of what it's about, what's possible, without going deeply into it. It usually takes like a few hours because it's really superficial. But once I get a sense of what the language is about, what the core constructs are, then do a second pass to kind of just understand really what's it about, and then maybe play around with some code. But I actually go code second.
I would try to do some simple services and stuff with actors running in the background. And whenever I saw something I didn't understand, I would just go look in the source code for play. Then I would look at this crazy Scala type stuff and have to then read the manual for a few hours to figure out what was happening. But now I will never forget because I encountered it through a painful situation. So I have like the emotional trigger to never let go of that knowledge.
that's interesting. Yeah.
I think so. Every new language brings a different way of thinking to the table. So reading the manual should be the first thing that you should do, I think. Maybe because usually the manual is written by the author of the language, or at least some supporting material about the rationale or the ethos of the language. And once you have some superficial idea about the language, start building something. And at the same time, look at the source code of the language, or maybe the standard library or some other products or tools that have already been written in that language to get a sense of how things are architected, what the idioms could be. And basically read more code and then write. I think I've always benefited more from reading a lot more code than writing.
Yeah, I think the problem comes first. I don't choose a language, just more of a problem. And I think this language could be better to solve that problem. And then just to find the quickest way to solve that problem and learn the crux of the language. And then go learn further by looking at the manual and other stuff.
So, Chad, I was talking to you before, and like you said, like don't just learn a language, like deploy something production. And similarly, like don't learn a language in a year, like spend time with it, build something, solve a hard problem with it, or build something concrete. Like, how do you see like?
Yeah, well, what I was telling you about is Dave Thomas, who is one of the authors of Pragmatic Programmer, who coined this language of the year idea, He spoke at RubyConf 2010, and he said he had revised his thoughts on what the challenge should be. Instead of just learning a language every year, I think he has the same problem I do. He can't retain it. He challenged everyone to learn a language and deploy it to production every year. Because to him, again, it's the same thing I just described for myself, that he personally can't hold on to the knowledge unless he experiences the real pain of putting something into practice.
Absolutely.
So pretty much like you learn programming languages like a lot of us, and probably our day job still requires us to programming in Ruby or Java or whatever. So one of the key things, like you write Lisp, you become a better Java programmer. That's the wisdom. So like, how do you exactly go about adopting features, like for example, like Closure or Scala or Haskell or Go, and like the language that you program in day to day, or maybe for the day job. So like,
how do you adopt the new language?
How do you adopt features?
Ideas. Okay.
Ideas, yeah.
Yeah. So as I said, every language has a different way of solving problems. So for example, if I take the example of Closure, in Closure there is a lot of emphasis on data. Okay, you don't hide data inside objects and stuff. You basically treat everything as first-class data structures and then manipulate the data using standard library functions and spit it out into a different format if you need to. So that's some design or architectural thinking that can be applied to any language, right? I know people who are actually professional Python programmers who learned Closure, did some real programming in Closure, and went back to doing Python and came back to me and told me that my Python code is so much better now, right? So I think it's not just about Closure or any specific language, but the idea is that get a taste of the language, see how they think about solving problems, and you may not be able to transport all the ideas. Like if you like channels in Go, you cannot build a channel-like thing in Java, for example. It would be very hard for you to do it. But at least if you have an appreciation for it, maybe who knows, tomorrow you might be able to use a third-party library to use it.
There's actually a problem that can happen though. So you can take good things like the data orientation or the ideas of immutability by default in Closure, and then just try to make your Ruby code be like that because you understand the benefits. Or you could do stuff like try to even possible to emulate the features of one of these languages that you're learning from, but you emulate them in an environment that's not friendly to them, and it's a bad idea. So I would say, don't go too crazy trying to make Ruby be functional more than it is, or to be actor-oriented or whatever.
There will always be impedance mismatches, right?
Yeah.
You'll figure it out if you try to apply those ideas.
No, I'm going to agree with Chad. So.
Yeah, okay. I'm not into this functional side or the Lisp side of the Closure side of things yet. So, but my experience is essentially trying to apply more ideas from Ruby into Java. And there was probably Java was at that level that we just talked about. It's such a what is called restrictive language. There was a lot that actually I could learn and apply into Java from Ruby, which was really exciting. There were libraries I think that was coming up for like calling anonymous functions or proc-like things that I could actually use them. So it was not really very tangible. A specific example I could give, my Java programming extensively improved, or readability of the code improved by having written more Ruby code. So some of it actually will happen naturally, I believe.
Another thing that I will add is that, for example, I was doing a lot of Python before I started doing some real Lisp programming. Python always had the map and filter and reduce functions. I was never able to appreciate those functions when I was just a Python programmer. Okay. For example, Closure has something called protocols. Okay. How many people have heard about refinements in Ruby 2.0?
Refinements, yeah.
Yeah, it's a new feature. So see, minority. Okay, it's a really good feature, and it lets you do quote monkey patching, but restrict it to a specific module. Okay. So I think that Ruby guys if they don't adopt it or don't understand the benefits, then it's kind of like a shame, right?
Yeah, but that's the point, right? Like that's something which had to happen at the language level. Like as a application developer who's not working on the language itself, adoption of features from other languages will run into bottlenecks. So that's definitely one area where, for example, in the Java world, right, when you move back from a lot of the Ruby programmers move back to Java, and they've created some beautiful libraries. For example, I know an ex-thought worker who's done a library called Enumerable, I think, which allows you to do kind of mimic closures in Java, and it works through actually hooking up a Java agent at runtime. So the point, it's a beautiful experiment, but you can't really use that in production because your ID is not going to recognize it. Simple things like that, which might seem like trivial, but they actually hurt because now the code syntax highlighting is kind of gone for a toss. The debugger obviously doesn't work. You can't. So you got to hook up the agent while running the app. So it becomes tricky. So I think a lot of the language features which get adopted do get adopted as frameworks. For example, actor systems, even though we don't have it in Java, kind of analogies of that have been, funnily enough, systems like Mule, right, which is again enterprisey and boring, but essentially it solves the same problem. Like not at a language level, but it allows you to coordinate independent actors and construct topologies of flows which kind of do something productive and allow you to scale out in a very simple way, right? So frameworks end up kind of taking the place in a certain way. I think it's difficult to bring it down to a language very well.
Okay. It kind of related to is like using play framework in Java, right? It actually brings a lot of Rails goodness and Rails inspiration into Java. So you don't, it's not necessarily about the language ways, it's also things like convention over configuration, which can be learned and applied into other languages. So just ideas are behind a specific paradigm. It's just simplicity or the philosophy behind it can be applied into other languages like Java from Ruby. So I think this framework side of it plays, I think, a big role.
Oh, that's a great point because funnily enough, right, like a framework like Rails or Sinatra was never invented in Java. Why is that? Because the thought process that's behind Java is just not tuned to kind of thinking in such lightweight, simplistic services. And it only took somebody to kind of look at Ruby, see its simplicity, and be able to kind of build something so simple as Sinatra. Like, it's beautiful. And now that thought process come over. So yeah, Play is a great example, actually.
Yeah, I think there's two things, the discussion kind of weighed towards more of the paradigms more. But I think there is things like simplicity, convention over configuration, or concepts, which is on their side certain languages have, which are not specific to how to make parallelism better, which are not specific to how to do functional programming, but still something that was not done before or easy enough in your language, which you could apply in other languages easily, I think. But those are nothing with libraries or nothing to do with any specific functions, but you could still get better in other languages by looking at this other philosophy behind the language, just beyond the specific paradigm of the strength of the language.
So we are about to close the panel discussion. Any questions? We have time for questions, Swanan? Actually?
Or how about you just raise your hand if you want to ask a question, and otherwise we'll all get tea. You have a question.
Or we can just move the discussion to the break room. Yeah. We could do that. So let's just, okay. What's your question?
So I worked in different programming languages. So about 4 to 5. So I think programming languages rose to such heights either because of the programming language itself or to the supporting libraries. For example, Ruby was not in so much mainstream until Rails came into existence, and Python for scientific calculation, C for system level Linux kernel stuff, C++ for games and other stuff. So what all these programming languages have in example like Scala, Clojure, Go, Erlang. So these are upcoming, like Dart also. So what do these programming languages have so that they will come on top? What do these libraries, what are the bigger libraries that they have so that people like me can use them for certain purpose? So what all they are useful for?
That's a very long-winded question. I'll very quickly answer that. Every language probably has a killer app, right, to champion it or maybe make it famous or popular. Not all languages have one specific killer app, for example. What would you say the killer app for JavaScript is, right? Or what about Objective-C, right? Just that you don't have any other choice in those cases, right? If you want to program for the browser, JavaScript is your only choice, Objective-C if you are doing Apple programming, right? So yeah, I mean, every once in a while there are projects or libraries or products which do come and make something very famous, but need not be true for everything.
Anybody has any other questions, then I can get hold of these guys.